Acute effect of nitric oxide supplement on blood nitrite, and hemodynamic variables in resistance-trained men. Cardiorespiratory Metabolic Laboratory, Department of Health and Sports Sciences, the University of Memphis, Tennessee. Introduction. Nitric oxide, NO, is indeed an important signaling molecule promoting vasodilation by acting on vascular smooth muscle and promoting other physiological functions such as inhibition of platelet aggregation and platelet adhesion. Via these mechanisms, NO mediates increased blood flow at rest and during exercise, which is of particular interest for athletes of all sorts, including both endurance and strength athletes. However, this is clearly most popular within the sports supplement industry targeting bodybuilders and the supposed dramatic increase in the muscle pump. Moreover, NO mediates neurotransmission of muscle atrophy and hypertrophy and the stimulation of satellite cells. Collectively, NO is marketed as in most sports supplement advertisements to increase blood flow and subsequently results in increased oxygen and nutrient delivery, e.g. amino acids, fatty acids, glucose, to skeletal muscle during exercise. This is suggested to aid exercise performance and promote enhanced exercise recovery, which may then stimulate further muscle hypertrophy. To date, there is no evidence of the support above, with the exception of an increase in plasma nitrate and nitrite after supplementation with glycine propionalate L-carnitine. Of course, an increase in NO does not automatically equate to an increase in blood flow, exercise performance, and/or exercise recovery. Such statements are mere speculation. Recently, a new molecule, 2-nitroxyethyl 2-amino methylbutanoate, has been developed and is being marketed as real nitric oxide rather than simply NO precursor. Aside from delivering NO to both the bloodstream and muscle tissue, claims for this product include immune pumps, improved muscle performance, and stimulation of muscle growth. Because such a product that appears popular within the sports supplement bodybuilding community will likely soon lead to copycat products being produced and marketed. It was our objective to test the efficacy of new supplement in terms of its ability to increase blood nitrite metabolites of NO. We rationalized that if acute intake of a supplement did indeed result in measurable increase in nitrite, then hemodynamic variables would be affected, such as the case of patients using sublingual nitroglycerin. Additionally, if nitrite was in fact elevated after intake, there would be further rationale to then study the impact of regular use of the supplement on exercise performance and recovery, assuming that a relationship actually does exist between circulating NO and exercise performance and recovery. To the contrary, if the supplement does not cause any measurable increase in blood nitrite, it would be unnecessary to study the short or long-term effects of such a supplement in terms of stimulating muscle performance, recovery, or hypertrophy, at least based on the rationale that these variables are impacted directly by the rise in NO from the use of 2-nitroxyethyl 2-amino 3-methylbutanoate. Based on the above, it was our purpose in the present investigation to study the acute effects of 2-nitroxyethyl 2-amino 3-methylbutanoate supplementation on blood nitrite, and hemodynamic changes in resistance-trained men. Because we had no direct data to refer on, a non-directional hypothesis was used in the present design. Methods. Experimental approach to the problem. Using a sample of resistance-trained men, those individuals who would likely candidates for use of such a dietary supplement, we use a crossover design with 1 week separating conditions to test the effects of the dietary supplement 2-nitroxyethyl 2-amino 3-methylbutanoate compared to a placebo to increased circulating NO metabolites, plasma nitrate and nitrite. We also measured the heart rate, blood pressure response to treatment. The present design simply assessed the acute 1 hour post-ingestion effects of 2-nitroxyl ethyl 2-amino 3-methylbutanoate on blood nitrate, an often used surrogate marker of NO, noted to be correlated to peripheral endothelial function. In addition, we measured hemodynamic variables. We did not determine nitrite concentrations within skeletal muscle because such work would necessitate the performance of muscle biopsies. Furthermore, no measures of physical performance were included in the initial study. These should be considered limitations of the present design. Subjects: 10 resistance-trained men performing 5 ± 3 hours a week of structured resistance training for the past 8 ± 6 years, mean ± deviation, participated in the study. Subjects were non-smokers and did not have any cardiovascular or metabolic problems that might affect their response to treatment. Subjects did not use any new dietary supplement during the testing period. Health history, drug and dietary supplement use, and physical activity questionnaires were completed by all subjects to determine eligibility. Heart rate and blood pressure were recorded after a 10-minute period of quiet rest. Height, weight, circumference measurements, and body fat percentages via a 7-site skinfold test were recorded and used as descriptive characteristics. Each subject was informed of all procedures, potential risks, and benefits associated with the study. All procedures were performed in accordance to the guidelines of the American College of Sports Medicine with regards to human experimentation and approved by the University Human Subjects Review Board H10-07. Subjects provided both verbal and written consent before participating. Subjects' characteristics are presented in Table 1. Procedures. Subjects reported to the laboratory on 2 occasions after a 10-hour overnight fast. All testing was completed between 5:30 a.m. and 8:30 a.m., and the time for each subject was matched for both visits. On arrival, subjects were asked to void and were then seated in a chair with a blood pressure cuff placed on their arm. Subjects remained seated in the same chair for the entire assessment period. At each visit, heart rate and blood pressure were measured and recorded, and venous blood samples were taken before, after a 10-minute quiet rest, and at 5, 15, 30, and 60 minutes after complete breakdown of the supplement. As described below, heart rate was measured via palpation using a radial artery for 60 seconds by 2 trained technicians, 1 on each wrist. Blood pressure was measured via auscultation using a calibrated manometer and dual earpiece stethoscope that allowed for 2 trained technicians to listen at the same time. And blood was collected via a needle and ethyldiamine tetraacetic acid (EDTA) containing vacutainer in this exact order at each time. Duplicate values for heart rate and blood pressure were recorded. The mean was used in data analysis. Subjects were randomly assigned in a single blind manner using a crossover designed to either the supplement 2-nitroxyethyl 2-amino 3-methylbutanoate or a placebo. Of the 10 subjects, 5 received the supplement on their first visit, and 5 received the placebo on their first visit. Each condition was separated by 1 week. All data collection was completed during September 2009. The supplement was purchased from a local general nutrition center stores and had an expiration date of February 2012, lot number 0030220009. The supplement consisted of fast-absorbed tablets, which were placed under the tongue for subbuccal delivery. The placebo consisted of a cellulose capsule of a similar size, which were swallowed. For both conditions, subjects received either 2 tablets or 2 capsules. Per manufacturers, individuals less than 90 kilograms of body weight require only 1 tablet, where those over 90 kilograms require 1 to 2 tablets. It is also stated that the tablets dissolve rapidly, and that the NO effects are felt within seconds and sustained for hours, but the tablets should be taken 10 minutes before the start of exercise. Through pilot testing, we noted that even individuals less than 90 kilograms experienced no change in subjective feeling of vasodilation and minimal or no change in heart rate or blood pressure when using only 1 tablet. Hence, despite the fact that only 4 of our 10 subjects were greater than 90 kilograms, we decided to use the higher doses of 2 tablets in the present study for all subjects, regardless of body mass. After intake of supplement of placebo, a 5-minute period was allowed for a complete breakdown of the supplement. Pilot testing revealed that the tablets were completely dissolved within 2 to 3 minutes depending on the individual, with a chalk-like residue remaining. Hence, we allowed for a complete 5-minute period. After this period, subjects swallowed any residue, then consumed 12 ounces of cold water. A timer was then started and continued for 60 minutes. As stated above, additional measures of heart rate and blood pressure and additional blood samples were taken at 5, 15, 30, 60 minutes after the start of the timer. Therefore, these measures were obtained at 10, 20, 35, and 65 minutes after the actual intake. Placement in the mouth of the supplement or placebo. Subjects were provided an additional 12 ounces of cold water to consume during the 60-minute period, during which time they remained seated in the same chair with the blood pressure cuff positioned on the left arm. The same amount of water, 24 ounces total, was consumed by all subjects during both visits. Blood processing and biochemistry. After collection, blood samples were immediately placed in a refrigerated centrifuge, 4 degrees Celsius, and the plasma was separated by centrifugation at 1,500 G for 15 minutes. The plasma was then stored immediately at -80 degrees Celsius until analyzed for nitrite within 3 weeks of collection using a commercially available assay kits. Kit 780001 Cayman Chemical, Ann Arbor, Michigan, USA. After conversion of nitrate and nitrite using nitrate reductase grease reagents was added to the sample, which converts nitrate into a deep purple azure compound. The absorbance of this azure chromophore was then detected photometrically at 500 nanometers using Biotech Instruments PowerWave 340 microplate reader, Biotech Instruments, Winooska, Vermont, USA, and unknown sample values were determined using nitrite standard curve via software, Biotech Gen 5 trademark. Assays were performed in duplicate, and the coefficient of variation was found to be 7.6%. Dietary records and activity. All subjects were instructed to maintain their normal diet during the entire study period and to record all food and drink consumed during the 24 hours before each test day. Subjects were provided their initial dietary record and asked to mimic this intake during the 24-hour period before the second test day. Records were analyzed for total kilocalories, protein, carbohydrate, fat, and a variety of macronutrients. Food Processor SQL version 9.9 ESHA Research Salem, Oregon, USA. Subjects were asked to maintain their normal physical activity habits during the study period, with the exception of the 2 days, 48 hours before each test day, during which they were required to refrain from any strenuous exercise. Statistical analysis. Outcome variables were analyzed using a 2-condition times 5-time analysis of variance. The data are presented as mean plus or minus SEM. Subject descriptive characteristics are presented as mean plus or minus SD. All analyses were performed using JMP statistical software. Version 4.0.3 SAS Institute, Cary, NC, USA. Statistical significance was set at p as less than or equal to 0.05. Results. All subjects successfully completed both days of testing. No differences in dietary intake were noted. P is greater than 0.05, Table 2. No interaction, P is equal to 0.99. Condition, P is equal to 0.18. Or time, P is equal to 0.98. Effects were noted for plasma nitrite, with values remaining nearly identical across time for placebo and increasing a maximum of around 6.7% at the 15-minute collection period for this supplement, Table 3. In regards to hemodynamic variables, no interaction, P is equal to 0.99, condition, P is equal to 0.42, or time, P is equal to 0.89. Effects were noted for heart rate. No interaction, p is equal to 0.99. Condition, p is equal to 0.17. Or time, p is equal to 0.84. Effects were noted for systolic blood pressure. No interaction, p is equal to 0.88. Condition, 0.21. Or time, 0.78. Effects were noted for diastolic blood pressure. Data for plasma, nitrite, heart rate, and blood pressure were presented in Table 3, Figure 1. Presents the individual subject data for nitrite under both conditions, collapsed and averaged across time. Figure 2 presents the individual subject data for both conditions, expressed as a percent change from pre to the 15-minute measurement time. It is apparent in viewing these data that a great deal of subject variability exists in the measure of plasma nitrite, with some subjects potentially acting as responders whereas others do not. Moreover, variability exists in resting values of nitrite despite controlling for physical activity and dietary intake of subjects during the days before testing. Discussion. The findings from the present study indicate that 2-nitroxyethyl 2-amino methylbutanoate has a small effect on increasing circulation nitrite and does not cause any change in hemodynamic variables within the 1 hour post-ingestion period in a sample of resistance-trained men. Considering the above, it is unlikely that this dietary supplement, based on the rationale that such an improvement is fueled by an increase in circulating NO, as our finding indicates, is minimally affected by treatment. Although we noted no time or condition effects for nitrite values were generally higher for this supplement compared to this placebo and increased at 5 and 15-minute measurements, time of supplement 5 through 6%, Table 3. It is worth noting that although nitrite was increased in some but certainly not all subjects, Figure 2, at the 5 or 15 measurement time, values were generally lower compared to pre in both 30 and 60 minutes, Table 3. Hence, any potential impact on circulating NO appears short-lived, where, if any effect is transient, 5 to 6% increase in plasma nitrite has in terms increased blood flow or exercise performance remains to be determined. Of interest, although admittedly not objective data, no subject reported feeling any different during the 1 hour period after taking either the supplement or placebo. Although many dietary supplements and ingredients are currently being marketed for purpose of increasing circulation, NO, the evidence for such an effect from oral intake of nutritional supplements is scarce. To our knowledge, only glycerin, proportional L-carnitine have been reported to result in an increase in plasma nitrite, findings observed in both previously sedentary men and women and in resistance-trained men. Unfortunately, no measures of exercise performance were included within the manuscripts. Therefore, it is unknown whether or not a direct relationship exists between circulating NO and physical performance. A recently published paper noted an improvement in anaerobic exercise performance and a reduction in blood lactate with a single dosage of glycerin proportional L-carnitine compared to a placebo using a crossover design. However, no measure of nitrite was included in the work. Further studies may provide an answer to the question of whether or not circulating nitrite is associated with exercise performance. As of now, such statements that are rampant throughout the sports supplement industry are mere speculation. Considering the above data, it is important to note the limitations of our work. First, we used a single blind design in which one technician administered the assigned condition and was aware of the condition being used. Although there existed no opportunity for the technician to influence the subject's plasma nitrite or hemodynamic variables, or double-blind design would be viewed as an ideal alternative. Unfortunately, this was not possible in the present study because we could not identify an appropriate inert placebo tablet that would dissolve when placed under the tongue. Because we purposefully did not discuss with subjects which treatment they received on a given day, we have no idea how many subjects correctly identified the true active tablet. Second, our primary outcome measures was plasma nitrite metabolites of NO rather than NO itself. Although this exact measure of nitrite has been used in other published reports, it may be considered ideal to have direct measures of NO. Unfortunately, because the extremely short-lived half-life of this molecule, direct measurement is rare. This requires the use of spin traps and electron spin resonance spectroscopy, a highly time-consuming and costly process. Third, because we only measured blood levels of nitrite, we do not know whether or not the supplement affects nitrite concentrations in other tissues, skeletal muscle, for example. Therefore, our failure to note any significant effect on blood nitrite does not necessarily mean that the supplement did not promote an increase in nitrite in other tissues. Our failure to include an assessment of nitrite in other tissues other than blood is indeed a limitation of this work. Fourth, as with many blood-borne variables, either measured at rest or in response to dietary supplementation, there exists a great deal of subject variability in our measure of nitrite, figures 1 and 2. Such a high degree of variability impairs any potential ability to detect statistical significance. To address this issue, we present the percent change in data in figure 2. Fifth, in accordance with the previous limitations, our sample size, although similar to many dietary supplement studies using a crossover design, may be considered relatively small. However, in our defense, statistical significance for any outcome measures was not close to reaching significance. Therefore, we do not believe that we are at risk of committing a type 2 error. Finally, we did not include any measure of exercise performance or recovery in the present design. Our rationale for this was simple. First, wanted to determine whether or not the supplement would actually promote an increase in nitrite used in this study was a surrogate marker of NO. If so, we could then design a subsequent study in which measures of performance and recovery are evaluated. However, if not, and based on the rationale of performance and recovery rate being influenced by circulating NO, we believe that it would be unnecessary to further evaluate the supplement on measures of exercise performance and recovery. Obviously, this was the case when reviewing data obtained in the present study, although it is possible that an acute exercise session may have resulted in a greater stimulus for nitrate and nitrite when subjects were assigned to the supplement. Further research would be needed to test this hypothesis, that is, the combined effects of 2-nitroxyethyl and 2-amino 3-methylbutanoate and acute exercise stress on circulating nitrite. In conclusion, 2-nitroxyethyl 2-amino 3-methylbutanoate has a small effect on increasing circulating nitrate and nitrite within the 1-hour post-ingestion period in a sample of resistance-trained men. Hence, based on the idea that increased circulation NO is directly related to exercise performance and recovery, our data fail to provide evidence that this dietary supplement would significantly affect either of these variables. Practical applications. Nitric oxide dietary supplementation have grown significantly popular in recent years and are arguably one of the most widely advertised and promoted agents in sports supplements today. Many athletes have used such products, tempted by the claims an increased blood flow, improved performance, and enhanced recovery. Although NO is indeed an important signaling molecule to our knowledge, there exists no direct evidence that NO performance promotes a direct effect on exercise performance or recovery. All such talk is mere speculation fueled by the dietary supplement industry. As always, athletes should carefully consider the science behind product claims before spending money on a particular dietary supplement. All Though many qualified dietary supplements do indeed exist with scientific evidence to support their use, many more are simply industry hype. Athletes are encouraged to consult with their knowledgeable and well-informed strength and conditioning coaches, in addition to doing their own research via the scientific database such as PubMed. By doing so, athletes may become more knowledgeable and regarding what supplements they are using and the specific reasons for use. Acknowledgements. This work was supported by the University of Memphis. The support does not necessarily imply endorsement of the University of Research conclusions. RJB has received research funding or acted as consultant to nutraceutical and dietary supplement companies including Sigma Tau Health Science, Manatech, Omni Active Health Technologies, Kaneka Nutrients, Minami Nutrient, Gero Formulas, National Safety Associates, Vital Pharmaceuticals, Champion Nutrition, Experimental and Applied Sciences, Purist Labs, C-Bio. All other authors declare no competing interests.